We're up and ready to go whenever.
Okay. Okay, let's get started. Okay, welcome to our weather discussion for the week. I'll do the current weather and a little bit of a look in the Pacific Ocean, and then Patrick will say something about the forecast. We've had a very interesting week around here. Pretty nice weather Monday through Wednesday, and then a sudden and well-predicted change that's kind of invaded since Thursday and now into Friday. I don't know how much water we've had fall out of the sky, but it's been consistently wet since all day yesterday and then even more so today. So we're going to talk about the storm, of course, that has brought that change. And it is a really interesting storm, and I'm not sure that it's not I don't think it's uncharacteristic. I think this is kind of the way sometimes storms will behave in the central part of the United States, central part of North America at this time of year. And you'll see what I mean when I talk about that as we go forward. So here's, I don't know what we're looking at here. This is the whole week.
It's the last week, yeah.
I'm not ready to say anything about it, so let's just move forward to the next thing. Thanks.
Yep.
Let's start with our regular satellite image over the last 6 or 7 hours. Take a look at that. And here it is, and Pete's convinced me to start using these colored ones. I kind of like the grayscale, but as long as it shows the same domain, I guess I can be satisfied with it. We've got a really interesting cloud head here. We'll see a little bit more in the full visible or in the other infrared, but you can even see here the low clouds on the backside of this storm. And most of the cloud head is out to the east and northeast of where we'll find the center of circulation in the middle troposphere and lower troposphere as well. So this is, I mean, if you're in Wisconsin, that's pretty much where the high clouds and the precipitation is likely to be. And so we're right in the middle of it today. What's interesting about this storm, and this is not uncharacteristic, is that there's a couple of different broad scale forcings that are going on to produce this whole collection of clouds associated with it. So we'll kind of dissect that as we go forward in the discussion today. And I think we'll start to point fingers at what it is that's driving most of the precipitation, and I think that won't be so hard to discern as we go forward in this discussion. And it really is about the only game in town that is, if you're thinking about the continental United States as town, there's a little bit of precipitation and cloudiness invading on the west coast, and there's just a little bit hanging on over far eastern Maine, and that's in association with the cyclone over the Canadian Maritimes and the southern part of the Labrador Sea. Other than that, there's really nothing else going on in organized weather across the entire United States. So that's interesting. We'll go back to the Pacific later on and take a look at some interaction that looks like it's about to begin between Typhoon, what's the name of it? Bolaven, I don't know how you say it. It's B-O-L-A-A-V-E-N. Bolaven. That's a Category 3 typhoon right now, southeast of Tokyo. And it's going to interact with the jet across the Pacific. And I'll show you a little bit about how that interaction's been predicted all week long. And it's very different today than it was on Monday. Even though broadly speaking, the same thing is predicted to happen. But boy, with totally different consequences, as it turns out. So we'll take a look at that. Okay, I would like Pete first to go to, I know this will be a slightly, well, we'll go to the radar. Well, let's look at the radar first. And then after that, we're going to depart from our normal usual course of events here. So here's the radar depiction of that cloudiness that we just saw on the satellite. Absolutely beautiful comma shape over the western Great Lakes states, and it's raining rather substantially now over the southern and central part of our own state. Looks like that'll go on for much of the rest of the afternoon. A little bit less organized or more scattered, I guess, on the western side of the storm. And then you can see you get precipitation extending all the way across towards Lake Erie and Lake Ontario. Toronto's here, so Toronto has a radar, but further north than that, there's not much radar coverage in Canada. And so when this thing moves a little further north, we may start to see it seemingly disappear, and it's hard to know whether or not that's actually disappearing as you move into even 100 miles from the border. But this is a really nice depiction across the central United States. It looks like a very vigorous storm, doesn't it, when you look at that? And it was windy last night, it's windy today, and it's raining, so it's a pretty good fall day. Friday the 13th, you can't beat it. You get weather like this on Friday the 13th. So a beautiful mid-October afternoon for us. Now, here's the thing that's interesting about this storm, among other things. Let's now go to Alicia Bentley's maps. We've seen where it's raining. We kind of get an idea, broadly speaking, what the storm looks like. Here is, can we go back a couple of clicks? No, I mean,
in time.
Yeah, in time, sorry. Yeah, so let's, right there, 18Z yesterday afternoon. The cyclone had a sea level pressure, this is 1,008. I want to make sure I'm counting it right, I don't want to do wrong. 12, 8, 4, 0, 6, 992 over western Kansas, central Nebraska. So 992 millibars. And that's about the time we talked about it in class at the same time, 992. Click forward in time. 16, 12, 8, 4, 0, 996. The central pressure is rising in this storm. Go ahead one more time. And this is closer to, one more time, it'll get us to 12Z this morning. And 24, 16, 8, this is now 1,004 millibars. Okay, so this thing is weakening as it moves across, and yet it looks like that both in the satellite and on the radar. So the sea level pressure is not getting any more intense. In fact, it's demonstrably getting weaker. We go to the next time, and the forecast will be a 6-hour forecast valid about now. This is 1,016, 12, 8, 4, 1,004. So the central pressure is like 1,002 millibars. Something like 10 millibars higher than it was about a day ago. So the whole thing's weakening. And the question is, how's that happening while it's still producing precipitation? So that's a really reasonable question, right? If you expect that much of the precipitation in a cyclogenesis, or a cyclone, I should say, I don't want to say cyclogenesis, but in a cyclone event, is a function of the vertical motions that sustain the low pressure center, how in the world are you getting precipitation sustained while the cyclone's weakening? Very interesting, and I think somewhat characteristic of a class of storms that make their way across the central plains of the United States in the fall. This is not uncharacteristic. So we're going to have to keep that in the back of our mind, and we'll dissect that as we go forward, okay? All right, so that's kind of the background for what's interesting about this event, in my opinion. Now, Pete, again, in a radical departure from some of the ways we often do this, let's go to the Omega page. And this is 0Z last night, so let's do the 0-hour forecast from last night. This is a robust vertical motion engine, okay, at 0Z last night. Right over sort of the northeast corner of Nebraska, 1, 2, 3, 4, I'm not going to count them, about 8 microbars per second of updraft, synoptic scale. Very intense updraft. And then the downdraft back behind, the 500 and 900 millibar thickness of the dotted lines. And so you get a really nice thermal wave here. It's even got a kind of an extended thermal ridge back in there. Really nice. Okay, so that's an intense looking storm. And it's just now clouding up over us, and we're starting to see the rain and so on around 4 o'clock in the afternoon. Okay, let's go to 6 hours ahead in this forecast. In this depiction. That looks a lot less intense. In fact, there's only 5 contours in the middle of that. And the ascent is moving into the Iowa, southern Minnesota border region, okay? And that's getting weaker and weaker. Let's go to the current time, or close to the current time, 12Z this morning. Wow, even wimpier updrafts. And kind of not so well connected. You can see there's a really strong thermal wind indicated by the thickness contours in this region, but it kind of gets spread out kind of rapidly over the region where the air is rising. So the whole thing is kind of falling apart from the PVA by the thermal wind point of view. And in the 12 hours from 0 to 12Z this morning, this vertical motion plume has gotten weaker, certainly gotten weaker. Let's go back to the original time, Pete, if we could. Just to remind you what it looked like, let's split this up into the pieces that have to do with PVA by the thermal wind and the pieces that have to do with frontal circulation. So let's go back and we'll look at the shear-wise part, which is kind of the PVA by the thermal wind. It's not exactly that, but that's a pretty sizable portion of the total. And then let's go to the transverse, which will pay attention mostly to frontogenetic activity. Ooh, a little bit of the warm front and some of the cold front. So you actually see some of the signals here. And the quasi-geostrophic system's really bad at representing frontal circulations. So it's always cartoony and hyper-cartoony. And so I kind of see a little bit of that there. But this is just as things are moving in, and there's some indication that even in the middle troposphere, there's warm frontogenesis along this band thickness, and then there's cold frontogenesis all the way down to the panhandle of Texas. Let's go to 6 hours in the forecast and do the same split. So here's the shear-wise, the whole thing weakened, and that gets weaker. Now let's see what the transverse looks like as we go to 6 hours. That even gets weaker, but it keeps the same characteristics. So there's a warm frontal cloud head, and then there's a cold frontal portion back that way. And the warm front moved over us by midnight last night, and so it was raining pretty good when we got there. So those are the things I want to key on. Is let's see if we can't find evidence for a substantial weakening of the forcing of the storm, especially the PVA by the thermal wind part, not this part, but the frontogenesis part, is the only thing that maintains the precipitation, in my opinion, through this whole thing. Okay, now, Pete, let's go to our upper level charts. Let's start at 500 millibars. Okay, 500 millibar chart from this morning at 7 a.m. I'm tempted to show you a couple of prior charts, but I'm not going to do it because I think people in 452 are getting carried away with that, and we're spending a lot of time on looking at a whole week's worth of math when it takes a lot of time to do that. But you can see this is kind of a bowl-shaped trough that's kind of centered right over central Oklahoma. It's not particularly sharp, but it is characterized by a downstream ridginess right over the axis of Lake Michigan. So that's interesting. That means there's a lot of change in direction from, northern Oklahoma to the time you get to Lake Michigan. Not surprisingly, all of that change in direction produces a lot of ageostrophic divergence, and that's where we were seeing the big bullseye of the updraft. Even though it was weaker, it was in that location at 12Z this morning, so consistent with this map. The baroclinicity here is a disaster compared to what it was just 12 hours prior. And we got to do that, Pete. I got to show you one time prior to this. As much as I sometimes want to resist that. Yeah, okay. Look at the baroclinicity down here. These are 5-degree isotherms. I'm in the minus 20-ish range here in northern New Mexico, and I'm minus 7 in the southern part of the state. So that's a really strong baroclinic zone. And I'm going to show you a Vis5B GFS simulation that started at 6Z that maintains some of this. But then if we go to the next time, which is current, or close to current, you notice the baroclinicity at 500 millibars just can't stay together. And that probably means the air is rising, so you're cooling where it's already warm and eradicating the baroclinicity. And the rising air is not inconsistent with the curvature of the flow. But it's not particularly promising for the sustained presence of a strong upper vortex. And that's, I think, why the 500 millibar feature gets weaker. If we saw a movie of this, you'd see it keeps getting weaker. Okay? So we've got a robust rain event, but weakening upper dynamics at the same time, it looks like to me. Let's go to 850 millibars, though. And we'll just do the current time. Okay, pretty intense low-level circulation center over Omaha, right? 50 knots at North Platte at 850. That's really strong winds. And you can see the circulation is very intense. Everything's 30, 40, sometimes 50 knots, as I just pointed out. And the baroclinicity is not wimpy either. It's 11 degrees at Moline, 11 degrees at Lincoln, 5 at Green Bay, 6 at Minneapolis. So there's really substantial horizontal temperature contrast, and there's reasonable confluence. Look at these winds. They're all straight from the south, and the one at Green Bay is from the east. And it's east-southeast at Minneapolis. So there's a squeezing of the isotherms in here. There's really strong frontogenesis going on in this region in the lower troposphere, because there's no baroclinicity in the upper troposphere. So it's all in the lower troposphere, and that baroclinicity is driving that precipitation shield that we saw in the radar. And the circulation center is back here over Omaha at 850. Really kind of interesting, strong geopotential height gradient to the west, weaker to the east. That's because the ascent's going on in this location, I think. So there's a number of different reasons why this storm is interesting. Let's go to 700. I think you see that the baroclinicity isn't particularly well put together at that level. Yeah, it's -1 at Green Bay, +6 at Lincoln. So there's still some temperature contrast, but the wind at Lincoln's 15 and it's 25 at Green Bay, so the colder air is in a way running away from the warmer air. So it's not so frontogenetic here as it is at 850. And then the cold frontal baroclinicity is nearly absent. One doesn't really see much of a temperature contrast along that whole feature. So the baroclinicity that's driving, I think, the precipitation generation is in the lower troposphere, below 700 millibars, while there's a struggle to maintain some upper divergence from the weakening upper disturbance. So that's kind of what it looks like to me in this storm today. So let's take a look at a couple of things from Vis5B that I think amplify that interpretation. So here is, this is 6Z GFS run from last night. This is the 0-hour forecast. So we had a sea level pressure minimum of about 1,000 millibars, and it started at 992, remember, at 18Z, just 12 hours prior to this. So it's weakening. Let's put the upper vorticity on there. That's QZ. This is at 500 millibars. Maybe we'll take the contour numbers off, Pete, so we can see through it a little bit better. So here you can see there's this sort of hand of God coming down from the high latitudes to the west, and very large vorticity values at 500-ish millibars right in this region over New Mexico and the panhandle of Texas. And here's the bulbous head of it over the plains. And so right where the cyclone center is, there's a gradient of vorticity that's fairly intense just to the north. Now let's take the sea level pressure off for the time being and put potential temperature on at the same time. And I think I have it at, yeah, I have it at 700 millibars. So this is like a proxy for the 500 to 900 millibar thickness. So I'm taking sort of an average theta at that level. And so here's the gradient of vorticity. Theta is a little bit bumpy, but one can see there's a decent horizontal temperature contrast in this location, and not so bad even over this way. So right at the front edge of this vortex structure, there's pretty decent PVA by the thermal wind. Let's put the sea level pressure again on there. And that's just ahead of where the cyclone is at this moment. And that's the way things go. They propagate in the direction of the thermal wind, and that would be to the north. And we're seeing that there's reasonable forcing at 6C for ascent just to the north of the cyclone. Of course, that means the cyclone is going to move in that direction because the lowest pressure is going to respond to where the pressure is falling. And so all of that makes pretty good sense. Let's take a look at what the PV looks like at the tropopause. This is 2 PV. I think that should be okay. Maybe you have to hit OK, but I already had it at 2.0. That was saved, so let's see what it does. Yeah, it saved it the way I had it. That's weird. So I'm colored by pressure. So these are the really high pressure regions of the PV. And you can see, just like the vorticity at 500 millibars, one can see a PV trench that gets deeper and deeper and deeper until it's right over the cyclone. Tilt this up a little bit, Pete. You can really see the 3D structure of that. Thanks. And there it is. Look at that. That thing is digging down, 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 and this is about as far as it goes. But it's a really beautiful structure, and we'll take a look at that. We'll interrogate that just a little bit right now. But let's go back to the top. So the cyclone at sea level is definitely in the vicinity of the greatest upper vorticity, as we just saw, and this is reflected also in the PV. Let's take a look at a couple of cross sections, I think, right there. And I took it through. Take the PV off for a minute. I just want to point out why I took the cross-section the way I did. And let's put theta back on there for the cross-section. Thanks, Pete. I'm kind of cutting it right through the maximum in the 500-ish millibar vorticity. And then we'll also look at the PV along that line. So let's tilt that up to the west, get rid of the other 2 fields, maybe make it easier to see them. And so there you have your upper tropospheric frontal zone. These are potential temperature isotropes every 3 degrees Kelvin. So we're talking about 3, 6, 9 to 10 degrees across at just above 500 millibars. That's a pretty intense upper front. But the PV pendant associated with it looks tired and bored and not really interested in stirring things up underneath. This is every 1 potential vorticity unit. This is 1 PVU, and it gets down to maybe 550 millibars. This is 2, and it's almost at the regular tropopause level. So this thing just doesn't have any more oomph. It's not going to have any influence on subsequent development after 6C. And that's consistent, again, with the notion that the storm is weakening as it moves towards us, even though it's maintaining a fairly decent precipitation shield and an energized precipitation shield. Part of that reason is there's barotonicity all the way to the ground that's unconnected to the upper front, but it's pretty robust. And if I didn't do this, let's do this now, Pete. Let's put the frontogenesis, 2-dimensional frontogenesis function on this cross-section. You'll have to go back to the top. Huh?
Horizontal or the whole thing?
The horizontal, only the horizontal. I don't want to know about the tilting. I don't care about it. It gets in the way. We're trying to diagnose omega, and there was already omega in the tilting, so it's incestuous intellectually. We don't want that. Okay. Let's see if there's anything here. This is on the fly. I mean, the units will be weird. We'll have to fiddle around with the units. Let's make it every 2, and then only positive values. 2, comma, parentheses. It's got to be parentheses first, sorry. 2 to 100. See what happens. Ooh, how very nice. Now this is completely on the fly, okay? Completely on the fly. This is intense horizontal frontogenesis. That means the winds, that we're not seeing here, are conspiring to force those isotropes closer together, right where the PV pendant is. And what kind of circulation is a result of that process? I have at least half a dozen people in 452 in front of me, so I'm not waiting that long. I need an answer.
Thermally direct.
Thermally direct, thank you, Erica. Thermally direct circulation, here's the warm side, the air is going to be rising here and sinking here. And if you have air rising in the vicinity of the PV pendant, you're just stuffing the PV back to the stratosphere. You're not pushing it downwards, you need subsidence right in the core of that to do that. Nope, we're pushing it back up. It's what do you call it? Recession of PV back to the tropopause. Eradicating the upper vortex, but still producing vertical motions that, if there's water vapor in the air, they're going to turn clouds into precipitation. So we have all of that stuff happening, even though it's working at counter purposes for development. How cool, right? Pete, we got to put omega on here now. That's just W. And then we'll put it on the same cross section. I guess we'll probably drop a couple of other things at first, but let's say the units have to be something like 0.02, and we'll look at just the ascent first. The 0.02, that's going to be too much. It's really small, and then from 0.02 to 100. Let's see what this looks like. Very choice. So here's the updraft. It's not as good as I thought it might be, but there's the updraft probably tied to the front of Genesis, and if we wanted to and spend more time, we'd find a downdraft on the other side. So there's a really nice signal lurking in this whole thing, which is really cool. And it helps to explain, I think, the companion observations that the cyclone's weakening, but it's not stopping the heavy rain. So that's still going on. Really cool. All right, and then let's go to the top view, and let's get rid of the cross sections. That's the last thing I'll say. We'll do theta again, and I think we'll bring it down to, it's already at 3 kilometers. Let's bring it down to like 2 kilometers maybe, something closer to 850. Okay, because we were looking at lower tropospheric frontogenesis at an earlier time, and let's do the 2D frontogenesis function on top of that, and that's at 2 kilometers already. Okay, so this is at 6C. So here's the 2D frontogenesis axis at about 2 kilometers, and here's the piece of the cold front. This looks rather like what we saw in the omega field from the QG, but this is the full wind. So we have frontogenesis along this whole band from the eastern part of Michigan all the way back to central South Dakota, and on the warm side of that contrast, that's where the air is going to rise. That's where the precipitation band is. And if we go ahead a couple of clicks, see how this is maintained. That's 12Z, and so we saw that in the radar. This is about now, and we're still a persistent frontogenetic band, now centered over the central part of Lake Michigan, but we're still the beneficiaries of the updraft portion of the thermally direct circulation that responds to that. So that's why it's still raining outside. So I've told you this before in 452. I want you going to the bus stop on an afternoon like today and imagining this map and saying, that's why it's raining while I'm at the bus stop. And why didn't I bring my damn umbrella? I don't know. But that's what I want you to do. Because if you think about these things in that way, with that kind of urgency, then you won't forget them. And you'll ask yourself other questions about it. And you'll keep on asking yourselves questions about it. And that's how you learn things. That's how you acquire knowledge. Okay? We live in an era, this is a little soapbox statement for me. We live in an era where the computer delivers us information. Many of us mistake information for knowledge. Many of us then mistake knowledge for wisdom. They are 3 separate things, and they come in sequence. And you have to struggle to turn information into knowledge. And you have to work for 30 years to turn knowledge into wisdom. Okay? So you can't be impatient about it, but you have to work at it. And that's what I'm encouraging you to try to do. Okay, so any comments or questions about this? Okay, I guess I'm done. Patrick. Oh, I'm not done. Hold on. I got to say one thing. I'm very sorry, Patrick.
No worries.
Pacific Ocean. And that will be from, where did I do it? I put this up here.
It looks like.
Yeah, this is it. Okay. This is a forecast, and I'm not trying to steal Patrick's thunder, but this is a forecast. Let's go back to the beginning of this particular sequence. Here is Typhoon Bo-Laven. What? I mean, it's got to be from someplace in the West Pacific. There's the typhoon. Here's the barochronicity in the thickness field. Go ahead forward, Pete, to 120 hours. Just click at a time. We'll just watch this thing. So this thing is down 949, 951, very intense, 950. It's staying around 950. Keep on going. 944, 945, there's a period of intense development south of the Aleutians. Baroclinic zone starts to show up and start to look kind of mid-latitude, frontal structure-like. Keep on going. Thermal ridge, 952. Look at the cloud precipitation forecast, starts to look comma-shaped. We'll keep going. And that's about as intense as it gets, something like 950. But then let's keep going to 120 hours. And then I'll play a little game with you. So right there, 976, this is valid 12Z Wednesday. Let's just, for the fun of it, see what the forecast, valid at the same time, but run 2 days ahead. So let's go 12Z October 11th. What did it look like then? Woo, 952 was the result at this time, just south of Kodiak Island. What about on the 9th? Woo, 931, okay? 80-foot waves encompassing the whole Northeast Pacific. What is going on? What's different between the forecast made on Monday and the forecast made today? They both have the initial condition of a really robust tropical cyclone making impact and connection with the baroclinicity across the Pacific jet. But everything's different. Let's quickly go to the current one. This would be 12Z the 13th, 931, 976. 45 millibars difference. That's 4.5% of the atmospheric column wasn't there on the Monday forecast and is suddenly sitting there today in the forecast. How come? So, an interesting question. Okay, thank you, Pete, for driving through Biz5D. Patrick, go ahead.
Thank you. Can we start with weather.gov, please, Pete? And then I'll go to our forecast pages. So I first want to look at watches and warnings at the current time. We can see associated with our cyclone, these are all winds. These are wind advisories in the grayer brown color, and then the lighter brown, these are high wind warnings. Gusts up to 60 miles an hour in Nebraska, Colorado, Kansas. That's an average day for this part of the country. I'm from Nebraska, so this happens, I don't know, a month out of the whole year. But still, 60 miles an hour is pretty intense. And you have freeze warnings just on the back end of this cyclone. So you can imagine it's a very blustery, brisk day outside in the central part of the United States. There's freeze watches in this little sliver of the panhandle of Oklahoma, Texas, and then New Mexico. So it's interesting to think that Texas will be getting a freeze before we will up here. In some places, I'm sure, in the central part of the state. But probably not uncommon. These places are higher elevation. But still interesting to think. And then largely, aside from this bullseye of watches and warnings, there's largely nothing. Maybe there's flood advisories near Chicago, but to our south. And then these are probably, let's see, where to be, gale warnings, I would think, over Lake Michigan here. Other than that, this bullseye in the middle of the country, largely nothing else going on. So could we go to QPF down on this page on the Outlooks part, please? Current Outlook maps, and QPF. So this is a look at the forecasted liquid precipitation. We can see our bullseye precipitation. You can almost make out the counterclockwise swirl associated with the low pressure moving towards our region. And these little bands of maybe heavier precipitation. There seems to be a bullseye near Chicago and up into Lake Michigan. That's interesting. And then the backside is largely divorced of most of the precipitation. It's all in the eastern and northern part of the cyclone, if we presume it's in northern Iowa, southern Minnesota. Aside from that, convection over Florida seems spotty. Nothing else. Maybe there's some indication of something coming on shore over the western United States, but that's it. This is the main player of our weather. So I'll be taking a look at just this cyclone, how it moves, and we'll go 12-hour increments through this cyclone here. See where it moves, how much precipitation we might get out of it, and that's what I'll do for the forecast. But first, from this page, so we are at like 1.5 inches of rain for Madison. If we go to day 2, we'll just watch this progression. We can kind of see the precipitation bands, they sort of fizzle out. We saw that from Professor Martin's discussion where you're sort of losing the robustness of the system. You can make that out where this is just largely a blob of precipitation. You didn't really see a structure to it at all. We are sort of in the wraparound portion. Maybe this is right at midnight or right at 7 a.m. We're largely divorced from the rain at this time, and you can see the max of precipitation is now off over the Atlantic. So it moves fairly rapidly in one day. And then if we go to day 3, we'll see this system is completely gone from the map. These might be some lake-enhanced precipitation bands coming off the lake. If you presume we had a cyclone move, we're going to have northerly flow on its back end, and you can see this band specifically straight down from Lake Michigan and Huron. Other than that, Pacific Northwest, something interesting coming in, but that's it. So this was the main player and will continue to be the main player, and this is looking now into Monday evening. So this is our weekend weather maker. So from this, we go back to our forecast model page, and if we could scroll down to the forecast, I'm going to keep going, please. I'm going to use, where is it? This Morgan Group MM5. So when I was looking this morning, the other maps weren't up, so that's why I'm using these maps. But these are great maps to look at, and we'll see why in a second here. So if we could go to 300 millibars at 6 hours.
Start with the mediogram for Michael.
No, we're not. No,
we
we're
could,
not.
we could.
No, we're not going to do that.
300.
Yeah, 6 hours, please. So here's a look at roughly the current time. This is 18 UTC today. We can see sort of the same features we are seeing during the current portion. This feature, this upper level low, was the same feature that was sitting over here last week. So if we remember, it sort of retrograded over Quebec and Ontario and then moved exactly back to where it is now. So that's the same system that was affecting us earlier in the week. Here's our system. That's nice upper level low, jet streak associated with it on its southern end. And we are sort of in, at this time, you can imagine upper level divergence maybe slightly to the southeast of where this upper level low is located, so maybe over Dubuque region. And we are in a region of nice ageostrophic divergence due to the directional change. So we would expect we're sort of in the bullseye for rising motion at this level from this look. Could we go to 500 at this same time, please? So 6 hours in the future. Here's our vortex feature. It's largely confined to where the lowest heights are, but there is still a pretty good gradient in vorticity on the leading edge. So remember, we saw that the precipitation with this storm was largely on the eastern portion and the northern portion. That's where you see this nice gradient in vorticity, and that will become important when I talk about the surface. But the feature kind of gets more mangled on the western portion. You kind of get flip-flopping gradients in vorticity. But if we remember, we have a line from like Minneapolis down towards Columbia, Missouri. That's sort of where the leading edge of this higher vorticity is. If we could go at the same look from the surface at 6 hours here, that's almost nearly where you see the precipitation. It starts Minneapolis down to Columbia. Areas to the east is where you see this heavy precipitation. There's most likely some frontal features going on, but this largely matches up with where we saw PVA by the thermal wind. If this was our leading edge of the vorticity, the thermal wind is all roughly to the northeast, so it's going to be advecting that vorticity to the northeast, causing rising motion. That's where we see our bullseye precipitation. From this look, this almost looks to be pretty slow, because we already saw that this band of precipitation was already over us. So maybe this is just slightly towards the west, but still a good representation, just shifted towards the west of our storm here. And from this look, we're at 1,000 millibars at this time. On the back end, we can see decreased precipitation, but you still have pretty good northerly flow. This is where we saw the freeze warnings from the weather.gov page, and you can see lower thicknesses, northerly wind. It's probably going to be a very cold night towards the west on the western portion of the storm. So let's go back a click, and we're going to jump ahead 12 hours, and we'll start at 300 again. And so we can see now, here is maybe our upper level low. We sort of lose that defined jet streak to its south. We're sort of in no man's land, almost in the left entrance region now, so you would expect you'd expect upper level convergence, maybe some descent in the region where we see our minimum and geopotential heights. And this jet streak is starting to interact with something going on over the Atlantic and up into maritime Canada. This is that same system that was affecting us earlier this week. So that system's going to intensify, but our system, we're sort of, we're losing the forcings from the upper levels at this time. And then you can see something coming in over the Pacific Northwest, where we saw bullseyes and precipitation over this time. So let's go to 500 at 18 hours in the forecast. We see that by this model depiction, there's still a pretty good upper level vortex feature. And so one contention I might have is because if this model look is correct, you're maintaining this vortex in the upper levels, so you're maintaining a sharp gradient in vorticity on its leading edge. And if we go to the same look at the surface, I'll sort of keep going along this. So I see I'm tracing where we had that max gradient in the vorticity, and directly downstream of it, where you have thermal wind advection of that vorticity, is where you see the max precipitation. This time, maybe over Gary, Indiana, and we see our low is slowly filling, but not as strongly weakening as it was when it was moving from Nebraska into Iowa at the same time. And we are now kind of in between, where the heaviest band of precipitation is to our east. We're sort of in this wraparound precipitation on the western side of now the low at this time. Now we'll go back. We'll do the same look 12 hours ahead, starting at 300. So now we see we kind of lose any definition of this jet streak. It's being ingested into something going on over maritime Canada. You can't even really, you can make out the upper level swirl, but it's hard to make out where the geopotential minimum would be. And we're still in that upper level convergence region, so slight descent over where we had our low. So we would expect slight weakening. If we go back, we'll look at 500 from this time, 30 hours. We're still maintaining that vortex in the upper levels, so you still have a pretty good gradient on its eastern edge. And we'll see that the precipitation will be focused to the east of that upper level cyclone and the low level cyclone. But we're already on the back edge of any flow, and this is tomorrow evening. Tomorrow about the same time, actually. If we go back one, and we'll go to the surface. So we see most of the precipitation is to the east of where we had that gradient in vorticity at the upper levels. The thermal wind's almost tightening on the northern edge of where the cyclone is located. So you would expect higher advection of vorticity about the thermal wind just to the north, and that's where you see the maximum in precipitation. It matches up pretty nicely.
Except, the geometry's wrong, in my mind. Look, this is a linear band of precipitation that's in the forecast. It was on the other one, too, and it's completely orthogonal at this time than it was 12 hours before. And that makes me think you've got a variety of things going on simultaneously, and maybe at this time, I think the frontogenesis is probably a dominant component of the forcing for the precipitation in the forecast, but not the only one. I think what you said is not wrong. It's just I don't think the geometry lines up enough to really ascribe, the lion's share of the forcing to the PVA by the thermal wind for this preset.
Absolutely, yeah. I've completely neglected the lower levels. You can kind of make out frontogenesis by the thickness, but I haven't gone through and diagnosed that entirely. But looking at this is about roughly game time tomorrow. I mean, blustery winds from the northeast off the lake, maybe slight rain. It's going to be raw weather for the game tomorrow. Very characteristic of October in Wisconsin, but not fun if you're sitting outside watching Iowa, who has no offense, play Wisconsin. So that'll be an interesting game, but it should be classic Big Ten football tomorrow. And I think that's the only thing I had. If we just go back, please, Pete, I'll show one more time. We go to 60 hours at the surface. So what I didn't show is the progression of our low. It's moving over the eastern United States, and then it gets picked up by another low that's developed over Florida, and the two sort of combined and begin a development which might be interesting for the northeastern United States. I haven't looked further than this. These only go to 60 hours. But the two, our low is 1,005, and then it gets down to 990 as it moves over warmer waters, interacts with another low pressure system that's moving up from Florida, and then you had that jet feature directly above where this low is situated. So this might be something interesting to watch, but we didn't see it in any of the QPF maps. So it's it must be moving out to sea just from this look, but this might change in a couple of days from now. And then you can see we're largely in northerly flow again. This is the 15th, the evening, we're in northerly flow. Maybe slight warm advection at this time. The lower thicknesses are in this contour here, but we largely stay with the same weather for a couple days now, and you can kind of see that we're supposed to be in the low 50s for 3 or 4 days before we start to warm up, as shown by higher thicknesses to our west. Any comments or questions from what I talked about?
We didn't show, but I was looking ahead in the Pacific too, and after that big event in the Gulf of Alaska, the whole flow gets really wavy from 35 degrees to 60 degrees north across the entire North Pacific Basin in a way that I can't say that I've seen more than a few times. So I wonder what's going on. And one of the impetuses for that seems to be a wave that comes out of the Arctic into Siberia. But that was a very cursory look.
Yeah.
And sometimes it's the other way around, where tropical cyclones in October really wreak havoc on the waviness of the Pacific jet, but not in this instance. So anyway, it's going to be interesting, and there'll be downstream consequences to all the wave trains that get initiated down there in 20th-ish of October. It'll probably be around Halloween. We'll start to see some of the impacts of that.
That's right.
So it's going to be interesting.
Yeah, you've had development after development over the Pacific Northeast that's just keeping the jet stream lower and lower, and so you get those outbreaks of cold air, and
Yeah.
that's most likely what's happening. They're beginning to interact with other features, maybe tropical cyclones or just disturbances and huge developments. Unfortunately for us, not very fun weather for next coming days.
Unless you're contemplative and reflective, and that feels great. It's partly cloudy, drizzly. The leaves are falling. That's not so bad.
True. Very fall. Yeah? Okay. Couple tornadoes in Iowa? Yeah. I know there were tornado warnings in Nebraska yesterday. I'm not sure if there was actually a tornado, but yeah. Very dynamic system moving over us. All right, well, thank you, Pete.
Thank you, Patrick.